Okay, so yeah, law of sines, there it is. So you take any of those two ratios and you equate them to each other. The way that you name your triangle, by the way, I can't remember if you went through this before, but if this is angle A, the side opposite is going to be called little a. And that's important because if you don't name your triangle that way, then the ratios won't work properly. Okay, so then the side that's opposite angle B is little b, and the side that's opposite angle C is a little c. And you can use any letters you like, obviously, but if you our formula just uses A, B, and C. Okay? So if it's a little letter, it's a side length. If it's a big letter, it's one of the angles. And basically, after that, we're just going to say, like, okay, we went through the derivation, and now we can just try a couple examples. So you'll get maybe a couple of questions like this, where it's just like, oh, here's a triangle, can you solve for some sides? Or it might be in the context of a word problem or something. And you'll notice right away that here they're using different letters, so that's okay, you'll get used to it. And one thing I'd like to talk about is like, well, how do I know this is a sine law question? What's one big giveaway? Like, do you see? Yeah, so if there's no 90-degree angle, you're definitely not using Pythagorean theorem. So can you find that angle there that's missing? Probably. Like, so 180, right? Like 180, subtract the other two angles will give it to you. So what do we got? That's 105. 66? Excellent, thank you very much. So that's 66. All right, and now let's see, it says find the length of QR. So QR is this side, so that would be little p. So it's kind of like, well, how do I know I can use the sine law? Well, if you're going to use the sine law, you need three pieces of info, right? So either you need an angle and two sides, or you need two sides and an angle. So I'm just going to write need two sides and an angle, or two angles and a side. That doesn't always necessarily work. Like, it's not just any two angles. You're going to need the right ones, but you're going to need two sides and an angle, or two angles and a side for sine law. When we do cosine law, we'll see a bunch of questions where it's like you'll have three pieces of info, but it just doesn't work for sine law. So if I rewrite my ratio, like I need this side, so I'm going to put the p in the top, and then which sign, what should be the letter if I'm using? Sine. Yeah, it's going to be exactly. And it's like, okay, well, I have angle P, so that's good. That's the side I'm looking for. And then you need a side where you know everything, right? And that'll be Q. So here's Q, and the side opposite, so that 8.1 is little q. Okay, so then I can say, all right, well, the sine law says that if I equate these two ratios, they'll be the same. So that's what I'm going to do. And now just plug in the information you have. So I don't know little p, but I know that the big P here is 75. So I'm going to write sine 75. And then little q is 8.1 over sine q, so sine 66. And then you'll pop it in on your calculator. What I do recommend you do, like for showing me work, is don't write a decimal for this yet. How do I get rid of dividing by sine 75? Just multiply, right? This is just a number, right? So if I just had p divided by 2, how would you get rid of the dividing by 2? You just multiply both sides by 2? Yeah? So then you do the same thing here. It's like, okay, I'm just going to multiply both sides by sine 75. So now I have this expression that I'll type it on my calculator. So I have whatever this number is times sine 75. And when you type it in on your calculator, do it in steps. Like, do this one first.
Excuse the interruption. Mercedes High Eagle, if you're in school, please come to the office.
Right, so do that one first, get an answer for it. I'm just going to quickly grab a calculator if I can. So that 8.1 divided by sine 66, who cares? I get like 8.86. Okay, and then just go equals and then hit times sine 75. So I don't like to show the intermediate steps. It's just too many decimals. Like, that would be enough for me to know, like, okay, they knew exactly what they were doing, and then if you got the wrong answer, I'd be like, okay, you know, obviously they made a mistake when they plugged it in on their calculator, so you just lose maybe like, depends how many marks the question is, but just a little bit. Now I rounded to 1 decimal because everything in the question was that way, so I rounded to 0.6. Did everybody get that? Good. How do you guys feel about Sine Law? That's basically it.
Good.
Yeah. All right. Hopefully we get our new projector soon. I doubt it will be. There's a your turn. I might have an answer for that if it's something you want to try. The answer's already in there, isn't it? Yeah. At the bottom? Yeah, I put it in there. Okay. We can quickly try it. Why don't we quickly try it? I think we have time. So it just says, okay, different triangle, different numbers, determine the length of GH. So GH is this side, and it's been labeled up, and that's a little j right there. So I just like to put a question mark. And just remind yourself, like, here's big J, so the opposite side is little j. Here's big G, so this side here would be little g. That's 7.8. Now if you're gonna solve for J, you're gonna need the angle J. We got the angle J. So you can start setting up your equation. So I got J over sine J equals, now which side am I gonna use? Because I need to use a side where I have both the angle and the side. Do we have that over here? Too hard of a question? What do you guys think? All right, we got G and the angle G, so we're gonna use those. So that's a good first step. And then just plug in your numbers. So I don't know J, but I know that sine J is 44, so it's sine 44. And then G is 7.8, and sine G is 51, so sine 51. That would be good. And now you got J divided by a number, so you'll multiply both sides by that number. So on the right hand side, you're gonna have 7.8 divided by sine 51 times sine 44. And then pop that in on your calculator and just give me an answer. I guess we already know it's 7.0, but maybe we can just confirm. Definitely try it. I want you to try it on your calculator. Make sure that you know how to use your calculator. Lots of calculators do order of operations. You got to be really careful with how you type stuff in. So I would just type this in, hit equals, then go multiplied by sine 44, hit equals. Yes, sir.
I didn't get the right answer on the example one, and I'm wondering what I did wrong there.
Okay, I'd have to come see after, I think.
Rounded to no decimal places of 7.
Oh. So it's good?
Yeah.
And everyone else agrees? Okay. Perfect. It's good news. We don't agree every day, do we? I'm going to show you a question now where, so we've done 2 where we're solving for a side. I'll do another one now where we solve for an angle. Okay? Before I do that, I just want to quickly just mention how we're going to do that. So here's one where we're finding an angle. Now there is a bit of an aside here. So the sine law is this, right? It's A over sine A equals B over sine B. Well, if you do the same thing to both sides of an equation, then nothing should change, right? So when you're solving for an angle, so let's say if solving for angle, use a different version of the sine law. If we just do the reciprocal on both sides, is that doing the same thing on both sides? Yeah? So it will be easier if you use the sine law like this. And just for good measure, I'll throw in the sine C over C. So if the thing you're looking for is in the numerator, it gets a step out of the solving process. There'll be one less step for later. If the thing you're looking for is down here, then you got to start cross-multiplying and it gets a little bit trickier. Right? But this would be the same. We did the same thing on both sides, so that's fine because it's an equation. Any questions? Good. Mr. Harrell told me that he made a lot of fun of you guys and that he was very certain that you guys didn't like it. He said someone came 10 minutes late. Who was that? So it was Roman, wasn't it? Oh, it's not a C. That's a B. It's always been a B. Yeah. Sorry, I must have been thinking ahead. Yeah, that should be a B. I hope that didn't get anybody. Is that good? Good eyes, Roman. Okay, so let's go ahead and try that now. So everything's been labeled up, but because that's generally not the case, I just want to confirm, like here's angle G and little g, so here's big H. What side would this be then? Little h, excellent. So just write that in, and then if this is angle J, this side here would be little j there. That's a good first step. By the way, nothing is drawn like accurately, so like I'll see it all the time, or like people look at this and they're like, it's a 90-degree triangle. Is it? Can we do that? No. Like, do not, like, nothing is drawn to scale. So if it looks 90 degrees, but it's not indicated that it's 90, or doesn't say in the information given that it's 90, you can never assume it is. Yes?
Just to clarify,
Yeah.
so the side angle, the side length is across from the angle, so like H is across
Yeah.
from the elevation?
Yeah, so if you just put a little dot in the corner where the angle is, and the side directly opposite is the corresponding little.
Sounds good.
Yeah. Yeah, and that is super important, because the sine law, that's how the triangle is labeled up. If you do anything different, then it probably won't work. All right. So what do they want? They want this angle here. Okay, so, well, if I'm going to find this angle, then let's see. I need to go sine g over little g. Now, there's already a problem here. What's the problem?
We have two variables.
Yeah, I don't know two things. Right? And in an equation, I can only have one unknown. So this is the thing I want to know, but I also don't know that. Do I even have a side where I know both things? Looks like H. So like maybe potentially like this, like I know sine H, I know H, but I don't know those two things. So that's not going to work. Ugh. So what do you think we can do in this case?
You can create a right triangle, divide 6.1 and find G.
Okay, yeah, it's not bad. Like you like drop it down. The only problem with that is like then I don't know where I am at, right? And then I still don't have enough information. Sorry?
You have to use J.
Have to use J? Okay. What do you mean? I think you're on the right track.
Like a little J. Like you have to use, you have to put sine J over the length of between G and H. So that's
Like just do this, and then solve. Is this what you meant?
yeah.
Like, okay, so I can't solve for this. Like, I don't have enough info here.
Yeah.
Can't do that. But I do have this,
Yeah.
and I could find angle J. And then once I know two angles, could I solve for the last one? Yeah, there we go. Perfect. So we're going to solve for a different angle and then find G. So this is kind of a trickier two-step question. So, all right, let's plug in what we know. So we don't know angle J, but we know side J. So I'm going to write sine J over 6.1. Equals, now sine H would be sine 65 over side H, which is 8.6. Now, if you use this version of the formula, all the questions are kind of the same. It's like now I need to multiply by whatever's over here. So I'm going to multiply both sides by 6.1. So I get sine 65 over 8.6. Throw brackets around that whole thing and multiply it by 6.1. Now here's the $1 million question. Suppose you could type that in on your calculator. I'm holding one. It's like, where did my calculator go? Sine 65 divided by 8.6. Okay. So let's see if we get the same decimal here. So I got 0.64. I'm just gonna go to like 5 decimals. I'm gonna round this next one. There. Did everybody get that? One thing I just thought of, just thinking about your question back there, on your calculator, be careful. Like some calculators, so if you go sine 65 divided by 8.6, some calculators might do this first and then figure out the sine of that. So just be careful. Like when I do it on mine, I literally go sine 65, hit equals, and then I divide by 8.6, hit equals, and then I multiply. So that might have been your issue back there. Did everybody get this done? Okay. How do I solve for actual angle J? What do I got to do here? Yes, very good. Inverse sine. So go inverse sine of whatever the ratio is, or the decimal if that's the case. So you can do inverse sine of that. Now if you still have it on your calculator, you can just go second function sine, and then you usually have that answer button so you can just plug in your answer. And I get 40.0, so I'm just gonna write 40. Any questions up to there? So now that we know this is 40, we don't even need to use sine law anymore. We're just gonna go, okay, well angle G is 180 minus 65 minus 40. So angle G is 75, 50. So remember when I said be careful? Because with sine law you need two sides and an angle, or two angles and a side, right? Like here's a question where I had two sides and an angle, but I couldn't use sine law to find the thing I was looking for. Okay, because you always need, if I was really specific, I would say you need an angle and its corresponding side, and then one other piece of information for sine law to work, for you to even begin doing sine law. Does that kind of make sense now? Right? Like if you don't have an entire ratio completely figured out, you won't be able to use sine law. Because that becomes a problem. So on the test coming up and in the future, people usually seem really confused, like they're not sure when to use Pythagoras or when they can use sine law or cosine law. And I recommend you try them in this order, because this is going from the easiest thing you can do, the quickest, to the longest. Cosine law takes a lot longer. So let's try another question. But that is basically, we've covered what we needed to cover today. We got lots of time left. So I'm just kind of looking, we can probably do the try yourself here. Let's see. Yeah, there's like a wordy problem. I'm going to say, just looking at what we got, the try yourself has an answer. I'm going to skip it because I'd rather do a question where we have to do everything from scratch. So here's a question where it just says, it gives you the information in words, so we have to draw the triangle, and I think that would be some good practice for us. So just give you a moment to read it. Now actually, we'll skip A. We're not too worried about the ambiguous case triangles. We just know that sometimes, if there's more than one way a triangle can be drawn, that's called the ambiguous case, so you can get some slightly different answers. Or if a triangle, two sides don't actually close, like don't actually meet, that's also ambiguous case. But remember we talked, oh, did we? I'm thinking about last semester. We don't worry about it in grade 11. So one less thing for you guys to worry about. I'm happy to just say, like, we don't need to worry about it. I just want you to know that it can happen. So it says solve the triangle. So when they say solve, that means we just want every single side and every single angle. Now when you're drawing your triangle, just draw, like, do your best. I'm very bad at this. But do your best to just kind of draw like a triangle that maybe, see, I always end up drawing isosceles triangles, or things that look like they're isosceles. I'm horrible. There. That's not bad. Now they're calling it PQR, so start somewhere and then move clockwise, counterclockwise, doesn't matter. But let's all do it the same for this, so that's how I drew it. And then I like to just go, okay, well, the side opposite vertex P is little p, and then here's going to be little r, and then this side is going to be little q. There. And then go through and see what kind of information they gave you. So here they're giving us this actual, like, instead of using this lettering, they're saying PQ. So here's PQ, which is R, that's 8. And then angle P is 55, so I'm going to write 55. And QR, so QR is 12, and we're calling that P. So there, that's all the information we have. So let's go through a little checklist. You draw this triangle. Is it a right angle triangle? Yeah, well, we don't know if it is. It could be, but we don't know, right? So I can't use my finger. So the next thing is sine law. Can I use sine law? So if you can use sine law, you will have at least one complete ratio. So that means, like, I would have R and angle R, or I'd have Q and side Q. In this case, I have angle P and side P. So I'm like, I can maybe use sine law. I got that and one more piece of information. Yep, I can use sine law. So now it just says solve the triangle. So let's go ahead and try to solve for, what is the only thing we can solve for right now with sine law? Very good. Because we need one whole side and then the other one. So if R is what I know, I can solve for side R. So let's do that. Now I'm looking for the angle R. So go sine R over R. And then the side that I know is P. So I'm going to go sine P over P. And then plug in the information you have. So I don't know sine R, but I know that little r is 8. And then angle P is 55, so I'm going to write sine 55. And then this side here is 12. Okay. And then instead of dividing by 8 on both sides, I'll multiply by 8 on both sides. So now you can write sine r equals, that will cancel out to 1. And this is what I'm going to type in on my calculator. So remember, go sine 55, hit equals, then divide by 12, hit equals, then multiply by 8. And if you do all that, you're going to get 0.54610. You're not done yet, because to find angle R, you need to do the inverse sine. So go inverse sine of that. And you're going to type that in on your calculator. And I get 33.09. So it looks like we're just rounding to the nearest degree, so we're just going to say it's 33 degrees. There. Yes? The calendar says that it's Thursday. Yeah, I don't see why not. We're not behind, are we? Yeah. Yeah, everybody's got a calendar, right? Yeah, we generally, like, every once in a while we get behind. Sometimes we get ahead. But in general, like, yeah, if the test says it's going to be this Thursday, like, you can always assume that's what it's going to be. Yeah. The last unit, I know the first one, we had some issues, but yeah. We do have some wiggle room at the end of the course, but yeah. Not a lot. So now, can I find angle Q? Mm-hmm. Yeah, so just go, we can throw the work down here. We can be like 180 minus the other two angles. And, oh, I don't feel like doing it. Is it 92?
Yes, Desjardins, would you please go to the office?
So, like, obviously my picture is not to scale at all. Like, that's clearly, looks like less than 90, but everyone's good? Okay. Is there anything else I need to solve? Yeah.
Right beneath where you went to sine r equals 0.54610 is up one.
Yeah.
Yeah, that one. So is that just when you took sine 55 over 12 times 8?
Yes. Yeah.
Okay, I'm just making sure I did this step right.
Yeah. No, that's perfect. All right. We got to do that whole thing again for Q. Is there an easy way to find Q?
Yeah.
Like, there is?
Wait.
I'm just being evil. Like, I guess I'm trying to say, like, do we need to use sine law again to find Q? We're not in a 90-degree triangle, right? If you're in a 90-degree triangle, you could use that grade 10 trig, but like, no, there's nothing we can do. We just got to do sine law again. So we're going to use a different ratio. So this time we'll go Q over sine Q. And now you have lots of options. I'm going to go and use the original one they gave us. So I'm going to use P over sine P. And now I'm just going to plug in all the numbers. So sine Q, we calculated it, and it was 92. So I'm going to go sine 92. And then side P was 12. And then we had sine 55. So let's give you a moment. You want to come in, Rob? Oh. You can walk behind, too. Like behind the camera. Yeah. Okay. Sorry, I saw Mr. Bockel out there. He looked lost. I think he forgot where he was again. We were so happy to have you here. All right. So that should be familiar. Let's see. Did anybody get an answer yet for me? 14.6. Perfect. Yep. That's what I got. And then we should put the units, I think it's centimeters. Yeah. Alright. So I don't know if you'll get a question like that on the test, but it's good practice. How are you guys liking that answer key? I was waiting for someone to be like, there's an answer. It says like every step, doesn't it? Isn't it like every question has every step? Yeah. It took one kid, I had a kid make it 2 years ago now? Yeah, it's almost like a year and a half ago. Yeah. He spent like all semester long, because he was always ahead. I'm like, you want to make an answer key?
What
Yeah.
should you
I give money, yeah, I give money.
What?
Money and prestige.
Like, you mean the answer key for the booklet?
Huh?
The answer key for the booklet?
Yeah.
Seriously?
Yeah.
Oh my god.
Yeah, it pays to be good at math, you know? Because their old one had lots and lots of errors. Like every exercise had like at least like 2 errors, and it's driving everybody crazy. So, all right. I think we have kind of like one of those wordy problems now. So there's another try it yourself. All the answers are down there, so you can try it out, draw it out yourself. I think there's some of the exercises. Is that what? Of course. So, no, I don't think I actually ended up doing. Do we have enough time? Yeah, we should have enough time. So, give me a second here. Take a read through this bad boy. Says 2 students are holding tethers to a helium-filled balloon. Okay, it's floating directly above the line through the student's feet. Okay. So, when I have a question like this, let's shrink it down. There. You need some room. You know what? Try for just 20 seconds to draw your own picture for a moment and see if it matches the one I draw. See what you can do. I'll give you like 20 seconds. You can compare it to a friend, or if you're Sarah and you have no friends, then I guess you just kind of glare at everybody. Just kidding. Did Mr. Hartle make fun of you guys?
Yeah.
What was the funniest thing he said? One person said no. He didn't make fun of you guys at all? He did?
Made fun of people who was late.
Oh, who was late?
Some people.
Mason?
What?
Remember you? I don't care. Okay. Was it you? Sarah? I told him, I'm like, you know what? I'm like, I don't think a single kid has ever been late, but I've only taught them for like 2 weeks, so I don't think anyone's ever been late. He's like 10 minutes late. Grade 11 pre-cal, 10 minutes late. I told that kid to drop the class. Did he say that? No? Okay. He's a good guy. I like him. He cares a lot. Okay, so let's see. If you drew a picture, probably you read this like 2 or 3 times, right? Like I certainly do, and I've been at it longer than you guys, but it says something, angle of inclination. What's angle of inclination again? Like what does that mean? It's like if here's a horizontal line,
Going down.
is that inclination? This one? Yes. Angle of depression is when you have a horizontal, and then it's like this, and it's like underneath the horizontal. I used to say depression gets you down, so like angle of depression, yeah. So that's an important thing, is like if you don't know what that word means, well, good luck to you, So it's kind of like, that kind of makes sense. It's like you got like the ground, right? And then you got like these 2 people. I'm just gonna draw Alex. I think Alex is a girl, and who's the other one? Carmen. Carmen's a guy. Okay, so it's like, here they are standing here. It could be. Okay? Here they are standing, and they're holding like a tether, and it says, floating directly above the line through the student's feet. So it's like, I don't know, it's like you got like this balloon up here. There. So let's see, Alex. So we're gonna call this A for Alex, C for Carmen. What do you want this side to be? H, perfect. For helium, or B for balloon. I don't know. Let's just go H for helium. Helium balloon. So let's see. Alex's tether is 25 meters long. So here's Alex. That's her tether. That's 25 meters, and an angle of inclination of 45 degrees. Carmen's is 20 meters long, and that's all we know. So determine the distance between them. So basically they want to know side AC. Now, I know it's not a 90-degree triangle, like not these vertices. So I'm probably going to use sine law. I have two sides and an angle, and I'm noticing that I have a side and its opposite angle. So that means I have an entire ratio. So I'm going to start labeling this up. Like this would be little a. What would this side be? Little c. And then this side here, the side we're looking for, is little h. I'm going to put a question mark because that's what I want to find. So right now I don't know enough, but I could go. I could use this ratio, and I could find what could I find that would help me? Like maybe this. So it looks like we have to solve the triangle. There are other ways of doing this question, by the way, but. Yeah, we're gonna have to do that. So we're gonna have to find angle C. So we're gonna go and go sine C over C, and then the side that I know everything about is Alex's side, so that's sine A over A, and then I'm gonna plug stuff in. So side C is 25, angle A is 45, so I got sine 45, and then side A is 20. We've done this lots of times now, right? Like we always set it up like this, so instead of dividing by 25, we'll multiply by 25. So on that side we get 1, on this side we get this times 25. So that's what you're plugging into your calculator. I'll give you an intermediate number. So sine 45 hit equals divided by 20 hit equals times 25 hit equals, and you get 0.88388. There. Finding the angle, right? So go angle C equals what? What is it? Oh, 60. Okay, no, I just meant like go inverse sine, but hold on to that. Did you say 62?
Yeah.
Perfect. Can we get confirmation on 62? Excellent. So now I know this is 62. So I'll update my picture. Great. So now I know that. Does that help me? Hello? Does it? How does it help me? Ah, yes, very good. So I can now find angle H, which will then help me find side A. So I can go 180 minus 45 minus 62. And was it 107? So is this 73? Is that right? I have a calculator, but I'm too lazy. Okay. Sarah says yes, so I'm gonna go with that. So that's 73. Now what? Use sine law again?
Yes.
Yeah. To solve for that side. Okay. So I'm gonna go H over sine H equals, then pick a side. I'm gonna use Alex's side because it was given. So I'm gonna use A over sine A. I'm gonna do the whole thing again. I'm getting tired just thinking about it. So it's 20 over sine 45. So there it is set up. Now I might get a little lazy here. Not lazy, but I don't want to write a bunch of decimals. So, got to multiply both sides by sine 73, and then I'm going to plug that into my calculator and hopefully have an answer. Does anybody have an answer? Alright, hold that thought and let's see what happens. Okay, what did you say you got? 27. Alright. I get 27.04. Like 8. Is that still okay? Yeah? I don't know how we're going to round. Like, it looks like that these are just rounded to the nearest meter. So I would say if you just wrote 27 meters, that would be good. But yeah, if you wrote 27.1 and you had your work, I guess that'd be okay. Alright. There it is. So does anybody have their exercise book? I just want to make sure that everybody knows which exercise we should try. And yeah, tomorrow we do close sine law, so tonight you've got maybe a bit of work in front of you, like doing this. So it looks like this is exercise. Oh, good, you got a piece of paper in there. Oh, that's perfect. This is doing yours. 12? No, 11. Exercise 11. Exercise 11. Stop the recording.